Okay, so day before yesterday, we started talking about chapter 11, that is ratio, rate, and proportion. So far, we have discussed ratio. We have seen a few examples where we deal with ratio. Ratio, rate, and proportion, all of them are very, very related to each other. The idea more or less behind every question would be same. It's just this every topic has one little thing in it that we need to understand. So for ratio, we know the symbol for ratio was basically this one, the two dots. And ratio basically means divide. So if the question says ratio of A to B, you can think about it as A divided by B. Anyways, we discussed some basic examples. These were easy. And here was, you can think about it as a real life application. It was if the scale of map is 1 ratio R, it means 1 centimeter on map represents R centimeters on actual piece of land. So it's just this, we are used to looking at maps, so we know whatever we see on map is not exactly how the distances are. It's just small version of something. And actually that distance is more than how it looks like on map. Okay, so we just, we used to make a standard ratio, and with reference to such standard ratios, we were solving questions. Okay, let me quickly talk about another example, and then we'll talk about proportions. Okay, so one second. Yes, basically this example was done. We did the first two parts of it. Okay, one last part was left. I'll give reference to the first two parts as well. Let me just write it down. The scale of map in the form 1:n. Okay. All right. So this was example 3. That we were discussing in the last class, and it was a length of 8 centimeters on map represents an actual distance of 2 kilometers. So you had to find the actual distance represented by these many centimeters on map. Step 1 is to make standard ratio. Okay, we made the standard ratio. This was for maps, this was for actual. 8 centimeters on map represents 2 kilometers of actual distance, and here the question was about finding the actual distance. So we were directly able to use the standard ratio and do cross multiplication, and we got our answer. But for the second part, it was the area on map in centimeter square, which represents 2.4 kilometers squared of an actual area. Now for this, you need to make the standard ratio first. The standard ratio that we already had was basically for distance. It was about length, it was about distance. Okay, so the distance ratio was 8 centimeter to 2 kilometers. 8 centimeter ratio 2 kilometers. This was our standard ratio for finding out distances. In order to make the standard ratio for finding out areas, we need to make the standard ratio for area, and for that you're only supposed to square both sides, and this is what we exactly did, and this gave me the standard ratio for areas. And now I was able to find any area on map if I had actual area. Okay, so this again was for map because it's in centimeter squares. This one is for actual, and just by comparing both of them, just by cross multiplying, I got x equals 38.4 centimeters squared. So this was the answer. Okay, all right, the third part now. The third part basically was the scale of map in the form 1:n. Now this is what exactly we have been talking about. Okay, all right, so let me write it down here. Now whenever the examiner is saying scale of map, this is basically for the length. Okay, here I agree the question does not mention if it's about distance or if it's about area, but you know, when it's not mentioned, it's just about the distance or the length scale. So let's see what exactly was the length scale. The length scale was 8 centimeter ratio 2 kilometers. Okay, so the standard length was the standard ratio was 8 centimeter ratio 2 kilometers, and you need to make it look like this one. So for that, you can just convert these kilometers to centimeters, because you know we need one here, and for that I'll have to cancel out 8. But for that, the important part is I need to first convert kilometers to centimeters. So again, 1 kilometer, kilo means 1000, has 1000 meters. Okay, and then 1 meter has 100 centimeters. So 1000 meter would have 1 lakh centimeters. Okay, 1 kilometer has 1000 meters, and 1 meter has 100 centimeters. So 1000 meters would have 100,000 centimeters. This implies 1 kilometer has 100,000 centimeters. So 2 kilometers would have, either you can directly, since one has this, so for 2 kilometers, it would be 2 multiplied by 100,000, and this would give you 200,000 centimeters. So this is 8 centimeter ratio 200,000 centimeters. And now you can just divide this 8 on both sides. So this is going to give you 1, and 200,000 divided by 8 is something difficult, which even I don't know. But 200 divided by 8, that's simple, I know. I'll do it here. It's 200 and it's 8. It's 2 times, it's 16. The difference is 4. The 0 would come down. It's 5 times, it's 40, and 0. So this,
25.
and very good, 25. So it would be 1 centimeter ratio 25,000 centimeters. And this is going to be the correct answer. Okay. So always remember, like, this is the second question of this type that we have just discussed. If you have a 1 here, means that you need to get rid of this 8, and that is only possible if you divide this number on both sides of the ratio. And for that, the important part is that the units must be same. So here initially we had centimeters, here we had kilometers. The units must be same, only then this thing would be correct. Okay, any questions?
No.
Anyone
No.
else? Umaiza, Urva, Ariba, Hassan?
No, ma'am.
No,
No,
ma'am.
ma'am.
Okay. All right. Okay. Perfect. So we are done with the
No,
idea
ma'am.
behind ratio. Okay. Rate is something similar to it. Rate is basically with reference to time. That is it. But we'll talk about it. For now, let's jump to proportion. Okay. Let me take out a new page. Here it is. And the next topic is proportion. Okay. And then by the end of this class, I need to talk about that homework question as well, which you guys were interested in. Okay. All right. So the next topic that is basically part of chapter 11 is proportion. And you know, once you understand proportion, you would understand the idea behind the limits of accuracy as well. Okay, now we have two types of proportions. Direct proportion and indirect proportion. Okay. Now in proportion, the idea is that in real life, at times, we have two quantities which we are dealing with directly. Okay. For example, let's talk about distance traveled and time. Time is a quantity, distance traveled is a quantity. If I will spend more time on traveling the distance, I would be able to travel more distance, right? So in proportion, every time we would be talking about two different quantities and we will see how they work together. In direct proportion, if I will be decreasing one of the two quantities, the other would decrease automatically. And in indirect proportion, it would be other way around. For example, in direct proportion, let's talk about distance traveled and time taken.
Ma'am, I'm so sorry, my net just got disturbed. Can we repeat the proportion one?
Definitely, definitely. Just give me 1 second. Let me admit one student.
Yes.
Okay, let him join properly and then I'll talk about it again. Okay, all right, okay. So here it is, okay. Proportion is basically something where we will look at the relationship between two quantities, okay. In real life, at times we are talking about multiple things together. For example, distance, time, temperature, time, weight, time, weight, length, you know, these quantities, we get to see them together. And what we need to understand is that what happens if I increase one quantity, would the other quantity increase or decrease? This is what we will be talking about in proportion, okay. So for now, just focus on direct proportion. In proportion, we will be dealing with two quantities and we look at their link. We look at their link. If I'll increase one quantity, would the other increase? If I decrease one quantity, would the other decrease? Stuff like that. Okay. So for now, let's focus on direct proportion. Okay. Here is example one for direct proportion. Now imagine I am going to somewhere. Let's say I'm going to another city and I'm traveling. Okay. So time taken, if I imagine that I am traveling on one standard speed. Okay, my speed is fixed. Like every time I'm traveling on 60 kilometers per hour, my speed is fixed. What I need to understand is that if I will travel for more time, if my time taken would be more, I would be able to cover more distance, given that my speed is fixed, obviously. Okay, fixed speed, that is certain. My speed is fixed, my car can only travel with one speed, it's going. If I will spend more time, if more time would be taken, more distance would be traveled. So since this arrow is going upwards, this arrow is also going upwards, this means we have a direct relationship. And if I spend less time, less distance would be traveled. So since the direction of both the arrows, like blue and blue, red and red, their direction is same, means this is direct proportion. If I will be reducing one of the two quantities, the other would be reduced automatically. Okay, let's talk about another example that would make sense. Okay. Okay. Winning a match and spending time to practice, or time spent on practicing. Okay, whatever you want to say, this is basically something that you guys would be able to relate. So imagine you have a match, you have a cricket match. Forget about luck. Imagine that luck is standards, it has nothing to do with luck. So if you will spend more time on practicing cricket, you would, get a better hold on the bat, you would get better at it, you would understand the rules better, and the chances of winning a match would be more. Similarly, if you spend less time on practicing, the chances of winning the match would be less. So what is happening? When I'm increasing this is also increased, and when I am decreasing this is also decreased. What does this mean? This means that this is direct proportion. Another example. Weight and eating. Okay, so for example, if I will eat more, I will gain more weight. Okay, and if I will eat less, I would gain less weight. So what is happening over here? When I am increasing one quantity, the other quantity is increasing. When I'm decreasing the first quantity, the other is also decreasing. This is basically direct proportion. Okay, any confusions with this?
No, ma'am. No
No.
confusions.
Okay.
No confusion.
Okay, all right. Now let's talk about indirect proportion. Okay, speed and time taken, speed and time taken, given that the distance which I need to travel is fixed. Okay, distance is fixed. Now imagine I need to travel 1 kilometer. My distance is fixed. If I take 10 minutes to travel that distance, my speed, okay, if I take 10 minutes, I would have a speed. And if I take 20 minutes, my speed would be less. This means if I will take more time to travel 1 kilometers of distance, my speed would be less. And if I take less time to cover that same distance, my speed would be more. Obviously, if my car is going on a faster speed, only then I would be able to cover that 1 kilometer in less time. So you guys would notice here, this arrow is down and this arrow is up. And when less time is taken, the speed is high. Okay, this is basically the idea behind it.
Yeah.
By
So
increasing,
the
hmm,
speed is indirectly proportional to time.
yes, speed is indirectly proportional to time. Very good. Okay, very good. Okay, one last example of same scenario. Now imagine I have speed and I have distance, and now time taken is fixed. Obviously, I need to fix one quantity, otherwise you guys would say, but time can also vary and distance can also vary, so that's not an issue. Time is fixed now. Now what's happening? I have 1 minute to travel, if I am covering more yes, one second. This is one second. I'll write it here. This is basically a question. Okay, let's think about it as a question. Time is fixed. You have 1 minute. In 1 minute, if you're covering more distance, what does that imply? Would your speed be less? If you're covering more distance, would your speed be less? No, your speed would be more, right? If you're covering more distance in 1 minute, it means that your speed was more. And if you're covering less distance in 1 minute, this means that your speed was less. So what do you think? Are speed and distance directly proportional or inversely proportional or indirectly proportional? What do you think?
Directly proportional.
Directly proportional.
Very good. Okay, since the
Directly
arrows,
proportional.
very well done. Since the arrows are same, means they're directly proportional. At times, for indirect, we use inverse. Okay, so you can say that speed is inversely proportional to time. Okay, now one last thing that we need to understand in these questions, you guys would have noticed I was increasing one quantity. Like when I started explaining this concept, I did not say what would happen if distance traveled would be more, would time taken would be more. No, in maths we have two type of quantities. We have dependent quantities and we have independent quantities. At your level, just know time taken is independent. Like time is going, time, I cannot control time anyway. Okay, distance travel depends on time. If I will take more time, more distance would be traveled. I can't say that for covering more distance more time would be required. Yes, in some cases I can say that, but time is independent, distance is depending on time. Okay, I can control the distance which I'm traveling, but I cannot keep a hold on time. So just know time is independent quantity, and in maths we deal with independent quantities in a different way. Okay, so this is my independent quantity and this is dependent on the on time. Again, if I talk about weight and eating, okay, so here you can say both of them can make a link, but similarly time is, most of the times you will see that time is independent. Okay, and usually for independent quantities we are basically using x, we will be using x. For this we would be using y, and for this we will be using x. You will get to know this in the coming example, but otherwise the idea behind direct and indirect proportion should be clear. Okay, all right, let's talk about one question and then I'll explain you how do we solve such questions. Okay. Example number 4 of this chapter. It says, given that y is directly proportional to x and y is equal to 5 when x is equal to 10, find y in terms of x. Okay, now this is the very first question where we will be dealing with direct proportion. Before this, I just told you the idea behind direct and indirect proportion, and this time around the examiner has given, or this is basically an example, this time around it is given that it is directly proportional. It could be that two different quantities were given and you had to think about it if it would be direct or indirect. Okay, for now I did not explain how to explain the how to solve this question. Yes, don't worry, I'll send you the recordings. Okay, don't worry about it. For now, let us focus on this because this is the very beginning of whatever we have been doing. Okay, so in direct proportion, when one quantity increases, the other quantity also increases, and let's see how do we do things over here. So this is the very first example. This is the very first time I'll tell you how to solve this. Okay. All right. Okay. So y is directly proportional to x. First of all, I am going to underline this and I'll write down the mathematical version of this English. Okay. When it says y is directly proportional to x, I am going to write it down this way. Y is directly proportional to x. This is y, this is x, and this is basically, this means directly proportional. Okay. All right. So this is basically the proportionality sign. For inverse, we will be using the same, but the change will be made here, but we'll come to that later on. For now, just know, you know it's directly proportional. Both the quantities are directly proportional. So we'll write down the first quantity, the second quantity, and the proportionality sign. Okay. Yes. Very good, Umayza. Well done. For the next step, I need to get rid of this proportionality sign and write down equal to here. So we do y equals k x. K is just a constant which I need to find, but I need to get rid of this proportionality sign because the question was about finding y in terms of x. It means I need to find an equation where y is the subject and it is written in terms of x. Okay. So I need to find this value of k, and I know y is equal to 5 when x is 10. Okay. So this x is independent and this y is dependent. For now, this example has nothing to do with dependent, independent. I'm just explaining this because in future I'll be referring to this part as well. Anyways, so I have equation 1, and in equation 1, if I plug in y equals 5 and x equals 10, what would I get? It's y equals kx, y is 5, k as it is, and x is 10. So I'll take this 10 on the other side, and this would give me 5 divided by 10 equals k. And finally, I would get k equals 1 by 2. K equals 1 by 2 is the value of my constant. This is basically called the proportionality constant because I got this after removing the proportionality sign. Okay. And finally, I am in the position to write down y in terms of x. Y was equal to kx. I don't need k. I need to plug in the value of k. That would be 1 by 2x. So this is going to be the answer because the examiner just said find y in terms of x, and this is how we do it. Yes. Anything that you were not able to understand here? All the
No, ma'am, I
students?
understood everything.
Okay.
Understood everything. Yes.
All right. Okay. Perfect. Okay. Let's talk about another question. It's example number 5. It says 2 meters of wire cost $10. Find the cost of a wire with a length of h meters. Yes. Please think about it for some time and then I'll tell you how to do it. Try solving this question.
So what are the final two letters with the length of?
Sorry, say it again. It's H and M. Once again. It's h meters. Okay.
And will we find out the independent and the dependent quantity, and then we will name them x and y?
Just think about it for now. Just think about it. Keep on thinking about it for a minute, and then I'll tell you, and then you can see if your idea was right or not. Okay. But more or less, you are 100% right. Step 1 is to see which quantity is dependent, which one is independent. Okay, all right. So let me talk about two methods for this, okay? Method number one is basically what we have already started, okay? We know ratios. We have been talking about ratios. So forget about direct and indirect proportion. I'll come to that later on. What I can do is I can make a ratio of length to cost, okay? I can make a ratio of length to cost, and the standard ratio would be 2 meters and $10. So 2 meter ratio $10, and I need to find the cost for h meters. So I'll write down h here. H is the length, and I'll write down x for the cost. So again, I'll cross multiply. This is what we discussed day before yesterday. This would give me 2x equals 10h, and this would give me x equals 10h by 2, and this is going to give me $5h. This would be the answer. And I did not thought about direct or indirect proportion. I just made a ratio, and out of that I was able to solve this question. Okay, so you guys can use this method whenever you feel like. Whenever some data is given, you can apply the ratio method. But let's talk about what we actually are studying over here. That would be method number two. Now, one thing is certain. When I will buy more wire, or when the length of wire would be more, the cost would be more. Obviously, you can't say if I'll buy more wire, the shopkeeper would charge me less. No, if I'll buy more wire, the cost would be more, right? This means that these two quantities are directly related to each other. Now, you need to understand which quantity is X and which quantity is Y. But before that, by now,
Yeah.
I know length and cost have direct proportion. So I'll write it down this way. Y is directly proportional to X, and I'll remove this proportionality sign and I'll write it down this way. Y equals Kx. And now the question is, what is Y and what is X? Is X the cost or is Y the cost? What thing is dependent? Yes, obviously, when I will buy more length, when my length would be more, then my cost would be more, right? Cost is dependent upon my length. Cost is dependent upon my length, okay? So this means that this is going to be the length of wire, and this is going to be the cost. Just think about it this way. If I will buy more wire, I would have to pay more. I can't say that I will pay more cost and then wire would be more. No, it's not like this. It's just the general idea. Okay, if I'm going to a market, if I'll buy more clothes, I'll have to pay more. It's not like this. If I'll pay more, I'll get more clothes. Like it is basically, you can technically think about it that way as well, but you need to see what is dependent and what is independent. Okay, this time around we did not have time. It was completely about two different quantities, but just know when you will buy more stuff, you'll have to pay more. Okay, so X is independent and Y is dependent. Okay, so again, you need to find the cost of a wire with a length of h meters. For that, first of all, I need to find the value of the scale. How do I do that? By using these two helping values which I was given. So cost was 10 for 2 meters of length, and K is going to be 5. So K is 5 for this. And now I need to find out the cost. So I know that Y is equal to 5x, where this is the cost and this is the length of wire. So if I am interested in knowing what would be the cost for h meters, I'll do Y equals 5h, and this is going to give me the answer. So we have both the methods. You can do whatever method you're comfortable with. And now tell me if you have any queries, anything that you would like to ask.
No, ma'am, all is clear.
All is clear, ma'am.
Okay. All right. Okay, perfect. Acha, now I have 10 minutes. I am going back to the past paper, to the homework question, which you guys wanted me to solve. Here it is. This one, basically, the second part of the question. Okay. Let me just quickly fill in the diagram because that part was needed. And then I'll do it. Okay, just give me 1 second. Okay, the first part was basically done and this turned out to be 12. This was 1, this was 4, and this is 5. Okay. Acha, let's talk about the second part. On the Venn diagram, the ratio of x, y, z is 1:2:3. Find the value of each of x, y, and z. Okay, now I'll tell you. You know, the difference in this and what we have been discussing is that we have been talking about such ratios, right? We know how to solve 2. We don't know how to solve 3, but the idea is same. You can just pick up any two values out of these three. I can do 1:2, I can do 2:3, I can do 1:3, and this would give me the correct answer. Okay, so step number 1 is this, and step number 2 is, I'll tell you the idea. I need to find out the values of x, y, and z. For that, my helping ratio would be 1:2:3. I don't know how to deal with 3 numbers. I'll just pick up 2. 1:2. So this is for x, this is for y. Now I need a number here. And then I can write down, x, or let's say a question mark, and then I can cross multiply, and then I can find the value. But the issue is that I do not have both these numbers. I need to find 3 of them. So for such cases, we need to talk about another concept. Okay, now at times, the idea would be that we would be given with these 3 small things, but we do not have x, y, or z. हमारे पास किसी की भी value नहीं है. We need some standard value other than the standard ratio to find out the other value. So how do we do it? I'll tell you. For now, we have a total of 40 students. So we know that 12, 1, 4, and 5 are basically used on different places. So 12 plus 1 plus 4 plus 5. I'm ignoring the 0 because it's nothing, it's just 0. And this is going to give me, this is 5 and 5, 10, 12. This would give me 22. What I know is that x plus y plus z, their combined value is going to be what? If I have a total number of 40 students, x plus y plus z would be what? Can anyone tell me? I have a total of 40. 22 are the other ones. So 40 minus 22. Very good. Excellent. 18 would be the total number, or the sum of x, y, and z. Okay. This is what I know. Acha. This is going to help me now. How? I will remake the standard ratio to address my problem. Now I have ratios for x, y, and z. In order to have something of this type, I'll do x plus y plus z ratio x or ratio y or ratio z, and this is going to be my new standard ratio which I will use to solve this question. Okay, now just listen to me carefully, things would get clear with time. It's x plus y plus Z ratio X. Okay. I have the ratio of X is 1. And what about this one? For this, what do I do? I'll do 1 plus 2 plus 3, and this would give me 6. So it means that it is 6 ratio 1. What is 6? This is 6. Okay. This number, or the number of total X plus Y plus Z, is 6 times more than what I would have for X. And I know a figure for total by doing 40 minus 22. So that was 18. And I need to find out this one. For now, I'm using a question mark because X is already used. So I will be cross multiplying this. And this would give me 6. Let me just write down X equals to 18. And this way I would get X equals 3. And this is the correct answer. So some ratio was given, but this ratio did not help me. Just like the area questions, the length ratio would not help me because I would not be able to find out the unknown area using the length ratio. Similarly, if I use this ratio, I need some value for X or Y or Z at least, and I do not have the value of 3 of these. So I had to remake my ratio this way. Using the same concept, I can now say that X plus Y plus Z ratio Y. Okay, now I can make this new ratio to find out the value of Y. And again, I'll do it here. This one is Y. Now the sum is 18. And I know that for Y it is 2. So, sorry, this was 6. The ratio sum was 6. And in general, it was 18. And I need to find this one. So again, I am going to cross multiply and it would give me 6y equals 18 multiplied by 2. So that would be 36. That's 36. So this would give me y equals 6. And similarly, you can find the value for Z. Please try doing it right now in front of me and tell me your values for Z. That is it. This is the last thing for today. Just try finding out the values for Z.
Miss,
Yes.
the answer for Z is 9.
Very well done. Excellent. That's correct. Very good. Okay. So now we get the idea behind ratios. We know how to play with them. If the actual ratio is not working, we can make our own ratio. And this method would be used in a lot of questions. Okay. So anyone who was not able to understand this idea?
No, ma'am, I understood.
Okay. Abdullah, Ariba, Hassan,
Yes,
Hassan.
ma'am, I understood.
Yes, ma'am, I understood.
Okay. So
I
I
have
hope.
understood.
Okay. All right. So yes. So I hope that you guys have no more questions then. I'll stop the recording.